Solving quadratic functions by factoring. In this first one, our quadratic function is already factored out. So when we solve quadratic functions by factoring, we factor it out and set each factor equal to 0. So we have k plus 1 equals 0 and k minus 5 equals 0. For the first one, we're going to subtract 1 on both sides to get k by itself. When we do this, we get k equals negative 1. For the second one, we add 5 to both sides to get k equals 5. So our solutions are k equals negative 1 and 5. For this next one, we have 4k plus 5 times k plus 1 equals 0. Again, all we have to do is set each factor equal to 0. So 4k plus 5 equals 0 and k plus 1 equals 0. For the first one, we're going to subtract 5 on both sides to get 4k equals negative 5. And then we divide by 4 on both sides to get k equals negative 5 fourths. For the second one, we subtract 1 on both sides to get k equals negative 1. So our solutions are k equals negative 5 fourths and negative 1. This next quadratic function is not in factored form and it's not in standard form. So we're given the function n squared minus 10n plus 22 equals negative 2. We need to put it in standard form, which is ax squared plus bx plus c equals 0. So what we need to do is we need to add 2 to both sides to get n squared minus 10n plus 24 equals 0. Now that it's in standard form, we can simply factor it out. We think of what times what gives us n squared. Well, it's n and n. Then we think of what times what gives us 24, but adds to give us 10, and it's 6 and 4. And since 10 is negative, we make both the 6 and 4 negative. So we get n minus 6 equals 0 and n minus 4 equals 0. When we solve for n, we end up getting our solutions to be n equals 4 and n equals 6. You can also factor it out using the box method. So we put the first term in the first box, last term in the last box, and then again our factors of 24 that add to give us 10 since 24 is positive. And it's 6 and 4. And we got to make sure we include our variable behind 6 and 4. So we get 6n and 4n. Since 10 is negative, both 6n and 4n will be negative as well. Then we take our greatest common factors out of each row and column. In our first row, our greatest common factor is n. In our first column, our greatest common factor is also n. In our second column, our GCF is negative 6, and in our second row, our GCF is negative 4. Again, we set our factors equal to 0 and solve for n, and again we get n equals 4 and 6.